रिकॉर्डिंग और मैं शेयर कर रहा हूँ। शेयर शेयर टाइम। So students, we'll start today with a new chapter, that is enamel. As we know that the enamel is the hardest calcified tissue of the body, which covers the anatomic crown of the tooth. Okay. First, we will study about the physical properties of the enamel. First is the density. It has a density of around 2.84 to 3 grams per milliliter. Okay. Then second is the thickness. The enamel thickness, it varies considerably over different parts of the crown. Maximum thickness of approximately 2.5 mm is observed at the cusp tip or at the incisal edge, and it is thinnest at the surface, which is approximately 2 mm. Third is the hardness of the enamel. It is about 343 Knoop's hardness number. The higher mineral content and the crystalline arrangement of the enamel makes it very hard. Okay. The hardness is maximum at the cusp tip and at the incisor edge, and it decreases to the cervical. Okay. Last is the tensile strength. It has a tensile strength of approximately 11,000 psi units. Okay. Now the chemical properties or the chemical composition. Enamel is highly mineralized tissue with 96% of the inorganic component and approximately 4% of the organic component. And it has water also. Okay. First, coming to the inorganic component, the major inorganic components are calcium and phosphate in the form of hydroxyapatite crystals. The other components include strontium, when we have lead, fluoride, magnesium, which may be incorporated into the crystal. The organic components include, they are seen as lace-like network between the crystals. Common is TRAP, TRAP. The full form is tyrosine-rich amylogenin polypeptide, and non-amylogenin proteins, which make up the major or organic components. Okay. Now the structure of the enamel. First, now coming to the enamel rods. The enamel rods, they are the fundamental structure of enamel. Each rod is extending from its site of origin at the dentino-enamel junction to the outer surface of the enamel. Okay. The enamel rods are separated by varying amounts of inter-rod materials. The number of enamel rods varies in different teeth. The rods are roughly cylindrical in the longitudinal section with an average diameter of around 3 to 4 microns near the dentino-enamel junction, which increases gradually to the surface or at a ratio of around 1:2. Okay, that was about the longitudinal section. Now coming to the transverse section of the enamel rods. The enamel rods have a keyhole shape, which is with a head formed by the rod and a tail which is formed by the inter-rod enamel immediately cervical to it. The rounded heads are commonly directed towards the incisal or the occlusal aspect, while the tails are directed towards the cervical region of the teeth. In enamel, the enamel rods and inter-rod enamel are arranged in such a way that the head abuts up against the tail of the adjacent rods. The body of the enamel rod is approximately 5 microns wide and Rod plus tail, that is the keyhole, is approximately 9 microns in length or long. The enamel rods, they show a wavy or a tortuous course as it travels from the dentin enamel junction to the outer surface of the enamel, as you can see in the diagram. Therefore, the actual length of the enamel rod is more than the actual thickness of the enamel. Along the course, the enamel rods bend up and down in a vertical direction and right and left in a horizontal direction. In addition, the enamel rods of adjacent rows may intertwine with each other in the inner two-thirds of the enamel thickness. Any tendency of enamel rods to cleave is reduced by a wavy pattern and non-parallelism of adjacent rows. Okay. Now coming to the submicroscopic structure of enamel rods. Enamel rods and interrod enamel are composed of millions of tightly packed hydroxyapatite crystals. Apatite crystals are flattened hexagonal structures with a length ranging from 6,000 to 1,000 angstrom. The direction of enamel crystals is different in rods and different in interrod substrates. In the cervical 1/3 portion of the rod, the lateral flaring goes to the extent that the direction of the crystals is almost same as that of the interrod enamel located immediately cervical to it. Okay. Now coming to the direction of the enamel rod. The direction of the movement is secretory ameloblast dictates the orientation of the enamel rod in mature enamel. Okay. The angle between the dentin enamel junction and enamel rod is approximately 70 degrees, and it can increase up to 90 degrees cervically. Sometimes it also exceeds 90 degree in the cervical region. Now, second are the Hunter-Schreiber bands. These bands, they are the alternate light and dark bands extending from the dentinoenamel junction towards the enamel surface. These lines are curved with the convexities facing the cervical region. Hunter-Schreiber bands are considered as optical phenomenon and are observed when longitudinal section of the enamel is examined under the reflected or under a polarized light. This optical effect is created due to variation in the course of adjacent groups of enamel rods and each band consisting of approximately 10 to 13 enamel rods. Because of this, when a section is prepared, some rods are cut longitudinally while some are cut transversely. When the light passes through the enamel, these rods, which are parallel to the light, reflect light away from the microscope and appear dark, which are called as diazones. And the rods which are less parallel to the light reflect light through the microscope and appear bright, they are called as parazones. Since the enamel rods are nearly parallel to the outer 1/3 of the enamel, okay, Hunter-Schreiber bands, they do not extend to the outer surface. Rather, it will be restricted to the inner 2/3 of the surface. The position of Hunter-Schreiber bands can be reversed by altering the direction of the light. It is thought that the relatively complicated rod arrangement observed in the region of Hunter-Schreiber bands serve to reduce the propagation of the page fracture. Next is the incremental lines of enamel. They are called as lines of Rediges. These are the incremental growth lines in enamel representing the rhythmic deposition of the enamel. In longitudinal sections of the enamel, striae of Rediges appear as series of brownish dark lines which extend from the dentinoenamel junction to the outer enamel surface. These lines run obliquely across the enamel rods and show an occlusal deviation as they travel to the surface. Striae of Rediges appear as concentric circles in transverse sections of the enamel, comparable to the growth rings of the tree. Each stria is separated by varying distance ranging from 20 to 40 microns separating weekly increments of enamel deposition and appears to be the result of cyclic disturbance in the rod formation occurring at every 7 to 8 days. The stria are closer and numerous in the cervical region. Incremental lines of radius are seen as encircling the dentin in the incisal or in the cuspal region, while at the cervical region, those stria extend to the surface, creating wave-like grooves on the enamel surface, which are called as pericymata or imbrication lines of Pickrell. Studies have shown that change in the inorganic components in the region of stria radius, and therefore they are considered as the hypomineralized structures of enamel. These lines they become more prominent in case of disturbance in the enamel deposition. Shift in the rod direction is also has been reported and associated with these structures. Next, we have enamel tufts. Now, enamel tufts, as you can see, these are the developmental faulting occurs in the enamel prior to its full maturation. Enamel tufts develop where enamel matrix proteins migrate to fill the faulting voids, which therefore contain reduced minerals and enhancing organic matrix concentration. Early faulting leads to formation of enamel tufts, while late faulting procedures produces enamel lamellae. Enamel tufts, they are hypocalcified structures extending from dentin-enamel junction to the enamel to a distance of approximately 1/5 to 1/3 of the enamel thickness. These structures are better appreciated in transverse section of the enamel. In ground section, they appear as tufts of grass. Therefore, they are called as enamel tufts. Enamel tufts are ribbon-shaped structures with free ends undulating on the sides. In thick ground sections, these structures originating at the different planes and curving in different directions are projected to one plane, giving the appearance of tuft or grass. Enamel tufts, they are seen in the region where the prism sheath is prominent and these structures contain more of organic components. Next is next is enamel spindle or enamel spindles. These are spindle-shaped structures extending from the dentin enamel junction into the enamel to a distance of 10 microns. These structures, they are odontoblastic processes that are entrapped in the enamel matrix. This structure becomes some of the odontoblastic processes penetrate between the ameloblast cells before enamel formation, and subsequent they get entrapped in the enamel matrix. They are called as enamel spindles. In a longitudinal sections, the enamel spindles are seen as dark spindle-shaped structures because the organic matrix is lost while sectioning and is replaced by the air. They are found mainly in the incisal or the cuspal region. Enamel spindles are arranged perpendicular to the dentinal surface and may not follow the direction of the enamel rods. These structures are thought to be improving the attachment between the enamel and the dentin, especially in the incisal or in the cuspal region. Now, the next is enamel lamellae. These enamel lamellae, they are hypocalcified structures and they extend from the enamel surface towards the dentin. These structures, they can be very well identified as leaf-like structures in the transverse section of the enamel and are more seen in the cervical half of the tooth than in the coronal half. Okay. The enamel lamellae can be grouped based on the time of development into pre-eruptive or post-eruptive lamellae. Pre-eruptive lamellae are formed due to stress or tension which is created during the formation of the enamel. When enamel rod crosses region of stress or tension, they may remain hypocalcified or uncalcified, depending on the degree of the stress. The regions remaining uncalcified manifest as crack-like defect in formed enamel and gel filled with the surrounding cells. The post-eruptive lamella are formed due to physical or thermal insult to which the tooth is exposed to. This leads to the formation of crack-like defect in the enamel and gets filled with an organic material from the saliva. Based on this, it can be categorized into three types: type A, type B, and type C. Type A, they are composed of hypocalcified enamel rods and they are restricted to the enamel. Type B, these are crack-like defects formed due to the early developmental faulting caused by the internal swelling pressure that occurs due to the ongoing crystal growth. Since these defects are found before the eruption of tooth, they get filled with cells from the surroundings. The cells in the deeper portion degenerate, whereas the superficial cells they forms the cornified cuticle or cementum-like material, which is found in these defects. So type B, these type B lamellae, they may cross dentine junction and they may also reach the dentine. Type C, these are also the crack-like defects formed due to the late development faulting or due to the various physical or thermal insults. In contrast to type B, in this type, the crack-like defects are filled with organic materials probably derived from the saliva. Type C, lamella may or may not reach the, it reaches the dentine. Enamel lamella may be mistaken for cracks formed while making ground sections. To differentiate both, the decalcification of the ground section can be done. The structure that remains after decalcification can be considered as the true enamel lamella. Enamel lamella considered to be a weak points in the enamel, which may allow the penetration of the microorganisms and therefore can serve as a pathway. Next is the dentino-enamel junction. It is the junction between the enamel and the dentine. The junction of dentine and enamel is intimate without any dividing plane between the two. The matrix of enamel intermeshes into the surface of the dentine. In microscopic sections of the tooth, due to the change in the orientation and different size of the crystals, the DJ appears distinct. The dentino-enamel junction is scalloped with the convexity facing towards the dentine. The dome-shaped elevation on the dental surface of the enamel fits into the depression on the surface of the dentine. The scalloped pattern is occasionally indistinct or even absent and is best appreciated in the regions where the stress on the tooth structure are the greatest. This scalloped junction increases surface area of contact between the enamel and the dentine and therefore strengthens the adhesion between the adhesion and the union between the two. The scalloped dentino-enamel junction also serves to reduce the change or development of cracks along the junction because of the numerous changes in the direction of the dentino-enamel junction. Next is the neonatal line. In a deciduous tooth and in the permanent first molar, enamel is deposited partly before birth and partly after birth. These incremental lines separating the enamel deposited before birth, that is an enamel which is deposited after birth, becomes accentuated because of the disturbance in the formation and that occurred at the time of birth, which is called as the incremental line, the incremental line, which is called as the neonatal line. The prenatal enamel is more homogeneous than the postnatal enamel, probably due to the more constant surroundings and good nutritional supply. Now next we have the gnarled enamel. This is the term which is used to describe an optical appearance which is seen in the longitudinal section of the tooth, in the incisal or in the cuspal region. Enamel rods, they follow a wavy or the tortuous course as it travels from the dentino-enamel junction towards the outer surface. The enamel rods, they undulate back and forth in a vertical direction and the right and left in a horizontal direction. In addition, the enamel rods of adjacent region may intertwine with each other in the inner two-thirds of the enamel. This irregular twisting and intertwining is more prominent and complex at the incisal or cuspal region, thus creating an optical appearance. This irregular twisting and intertwining may be associated with the increased strength of the enamel, which is required at the incisal or at the cuspal region. So, uh, that ends our enamel, and so we can say that the enamel, it is the hardest calcified tissue of the body which covers the anatomic crown. Okay, and it is a unique calcified tissue which is different from the other calcified tissues of the body. Okay. Okay. Thank you very much.